Hello everybody and welcome to AlgoExpert. In this video, I'll be covering the question of run length encoding. Now before we dive in, let me quickly give you the formal definition of run length encoding. This is coming from Wikipedia. Run length encoding is a form of lossless data compression in which runs of data are stored as a single data value and count rather than as the original run. So this is pretty straightforward. But if we just have a quick look here at our sample output, which is this, and our sample input, which is this, what we can see is that what we have in our sample output is a count, which is 9, followed by a value, in this case a. And what that is telling us is that this combination means we have a run of length 9 that has the character a. So if we were just looking at this sample output and we wanted to recreate the sample input, imagine maybe we couldn't see this for some reason, what we could do is simply write 9 A's. So I could say 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we would move forward. We'd have 4A. That tells us, again, we have a run of length 4. This contains the character A. We'd have 1, 2, 3, 4 more A's. And then we would have 2B. So again, we could continue and we could write 2 B's. And I think you get the point. I will continue writing this out without repeating the rest of that. So that is how we can look at the encoded output here and get back to the original input. Now, this type of encoding is known as a lossless encoding or a lossless compression, whatever you want to reference it by. The reason this is lossless is because given the output, we're able to get back to the original input. And that's very important for this question and something that we really need to consider. If you were asked this in an interview, you would really want to make sure that you're clarifying what they mean by lossless and that you understand that that means that given this output, you can get back to the original input, and given this input, you can get back to this output. So anyways, moving on, let's have a look at why in this situation we have a 9A, 4A rather than 13A. So of course, if we have a look at our input here, we have 13 A's. So some of you may be asking me the question, well, why is our encoding not 13A, 2B, 4C, and 2D? Now this would be where you would have to go back to the question prompt and read it very carefully. If you look at the question prompt, it tells us that we can potentially have any type of characters in our input. Now what that means is that we can have numbers, we can have letters, we can have case-sensitive letters, so uppercase or lowercase, we can have special characters like spaces, dots, slashes, exclamation points, you name it. All of that is valid and could be included in the input to our function. So there's no way for us to know if we were to use an encoding of 13A, whether this 13 here is actually a 13 or it's 1 and then 3. Now, what I mean by that is we could really have an input that looks like 1, 1, 1. In that situation, the encoding for that would be 3, 1. So how do we know that this is a 3 and this is a 1? How do we know to separate these two things? Or how do we know to read it as one whole number? And the answer is that we don't. There's no way for us to know. Now, some of you, if you're a little clever, might think that we could use something like a delimiter. So you might say, all right, let's do 13 period A. And then let's do another period to separate it out. And let's do, 2 and another dot or period or whatever you want to call it. And then a B. And then that way we'll know that 13 corresponds with A, 2 corresponds with B. And even if we had a situation like 13, 1, we would know that because we're separating it out. But the reason we can't do this is, again, the same reason we can't figure out whether this 1 corresponds with the 3 or the 13 corresponds with the A. Because we could potentially have whatever we use as the delimiter as one of the characters in our input string. So that's why we need to make sure that whenever we have a run that is greater than length 9, we split it up such that the largest character we're ever looking at in our encoding is a 9. So this is unfortunate when it comes to actually compressing this string and making our output string as small as possible, but unfortunately that is what we need to do for this problem. And I will say that if you are in an interview, they probably will not give you this hint and tell you that you need to split this up. So just make sure you're thinking about those kind of things and why it's important that the maximum digit we can have is 9. So hopefully that makes sense, but now let's talk about how we can actually solve this problem. So let's start by the goal here. Our goal is to take this input and create this output. So we want to keep track of all of these runs. We want to figure out this run of 13, this run of 2, this run of 4, and this other run of 2, and then we want to convert it to that. So how can we do that? Well, the first thing we're going to need to do is make some kind of data structure that can store the runs that we found. In this case, I'm going to call this chars. and I'm going to make this equal to a list. Now, some of you may be saying, well, Tim, if we're going to be making an output string, why don't I, instead of doing this chars list, make string, make that equal to an empty string, and every time I get a run, why don't I just concatenate it to the string? So let's say we found a run of 9a, we could do something like string plus equals 9a. You can imagine that that is inside of a string. Now, the reason this is no good, and the reason we're not going to do this, is because in most languages, a string is an immutable data type. What that means is that whenever we perform some kind of concatenation, we actually have to rebuild the entire string. So whatever the length of the string is, we're going to have to perform that many operations plus the other string that we're going to be adding to it to create this new string. So that's known as an on operation. So you can imagine that if we're going to be looping through all of these characters here, right? So I is just my iterator variable. You can imagine, we're looping through and looking through all of these things. That already is an on operation. Now, if we're going to be performing a string concatenation, potentially every single time we loop through, imagine the situation where we had something like A, B, C, D. So there was no runs. We actually had to have our encoding look like 1A, 1B, 1C, 1D. Then what we would get is an on squared time algorithm, because we need to do a concatenation every single time that we loop through a character, right? So we would have O of n squared time, which obviously is not good, and we can do much better than that. So the reason we're going to use a list is because when we add something to the end of a list is a mutable data structure, which means we can change it, and that is a constant time operation. So keep that in mind. This is a very important thing and something that you really want to keep track of and just know for any of your interview questions. So just to make this simpler, let me just rewrite out this variable. So we have this list. Again, I've called it characters, and we're simply just going to add characters into this list. And then at the end of our algorithm, once we have a list of all of the different characters, and really this list will just look like 9, A, 4, A, so on and so forth. It's just going to be separated out as individual elements. We'll just combine this list into a string. That will be an on operation, but it won't be an n squared time algorithm anymore, because we will just have performed multiple on operations, which we know and which I'll explain later makes our algorithm still an on time algorithm. So anyways, enough about that, but let's go ahead and talk about the process and how we'll actually come up with these characters and find these runs. The first thing we're going to need to do is have some kind of variable that can keep track of the length of our runs. So let's say length equals 1. Now, the reason I'm going to start my length at 1 is because if we read the question carefully, we can see that our function is going to take in a non-empty string. That means we're never going to be in the situation where we have an empty string. So at minimum, we will have one character in our string, which means we will have at minimum a run of length 1. We will always have that no matter what. So we will start our length at 1. And then what we'll do is we'll start iterating through our input string, but we'll start at the second character. So we'll put I right there. This way, we already know we have a run of length 1 of whatever the previous character in the string is, and we can check whether we need to extend this run or whether a new run has occurred. So the basic process is going to be we're going to loop through, we're going to compare the current variable that we're looking at to the current character that we're looking at to the previous character in the string. If these two are the same, we will add 1 to our length. If they are not, we will take whatever our current run length was and the previous character and add that into our character. So let's just imagine, just to make this a little bit simpler and kind of get the idea out here quickly, we had our string being AB. So this was our input. This is what we're looking at for this problem. Well, we start I here. We have a length of 1 already, right? So length equals 1. And now B does not equal A. Well, what we'll do is we'll say, okay, these are not the same. So we'll go inside of our character list and we will add 1, A. Then we'll continue and, well, we would add 1, B. So that's all there is to it. But now let's go through an example using the sample input. All right, so here, obviously, these two things are the same. So we'll just write a little if statement here just to make this clear. If string, imagine string is our input string at index I is equal to string at index I minus 1, then what we can do is we can say length plus equals 1. Otherwise, and I'm just going to write kind of a comment here. I won't write out the actual logic. We'll do that later when we get into the code example. I will say add run to chars. So that's kind of our basic algorithm as we loop through all of these things. So let's keep going. And, I will kind of can skip through here. I don't need to go 2, 3, 4. I think you guys get the point. But let's now get to the point where we have a run of length 9. So when we get to the point where I is here, our run length is currently actually going to be at 8. Let me just erase this and write 8. And then as soon as we perform this comparison here and we get into the side of the if statement, so obviously this if statement here is going to run, what we will do is we will add 1 to our length. So our length will now become 9. So length will become 9, and then we will increment I and move it over 1. So now i's over here, we enter our for loop and we have a length of 9. Now remember that whenever we have a length of 9, that is the maximum run that we can kind of add into our character list. We can't add something like 11a. The most we can do is 9a, and then we have to start from the beginning and continue to split it up. So what we'll do as soon as we hit a run of length 9 is we'll go ahead and add that run into the characters list and then reset our run counter. So at this point in time, right, we are actually at index 9, saying we were starting at index 0. So you could say this is the 10th element here. What we'll do is we'll add in 9a. So we'll say, okay, well, we have a run of length 9. So let's add 9 and let's add a. A was the previous character, right? We're looking at here to figure out what the previous character for the run we're adding in is. Then we're going to reset our length. So we'll say, okay, well, the length now, this should be equal to 1. And then we'll just continue to move on. We don't need to actually perform any comparison here simply because we know that the length was 9. So now we've taken care of, well, I didn't mean to erase that. We've taken care of all of this on the left-hand side here. So all of that is done. Now we're starting here with a run of length 1, and we'll increment I and move it over 1. So now I gets moved over here. We have a run of length 1, and we continue the process just like we did before. So we don't have a run of length 9. That's fine. So now what we'll do is we'll check this if statement and we'll say, okay, well, is string I equal to string I minus 1? Yes, it is. So what do? We add 1 to the length. Awesome. Let's add 1 to the length. And now we're at 2. Now I'll skip over 3 and I'll reach the point where we actually hit B here. So at this point in time, our run is length 4. And now this condition here is not true. So we get into this else statement, and what do? We add the run to our characters list. So we say, okay, well, that wasn't true. So let's go ahead and add in, oops, didn't mean to do that. Let's add in our run, which in this case is 4. Let's add in the character A. Let's reset the length counter to be 1, and then let's continue on. And now we've taken care of all of this. Now I is over here. We have a run of length 1. These two things are the same. So we go ahead and we change our run to length 2. And then as soon as we hit C, so as soon as I gets over here, we'll do the same thing that we just did. We say, well, these two characters are not the same. So let's add our run. So we'll add 2 and we'll add B. So now we move our way over to C here. These characters weren't the same. We added those into the list. We continue to increment I until we reach the point where we have 4 C's. So let's make that 4. So I will be over top of the D here. And now we'll compare these two values. We'll see that they are not the same. And what will we do? Well, we will add this run of C's into our character list and reset the counter. So we'll get 4 C. There we go. We reset our counter to 1. And then we can continue moving I. So now I only has one more place to go. So I goes here. We increment our counter to 2 and we're done. But notice that since we're done, we have no more places for I to go, right? It can't increment anymore. We never reach the condition where we actually add this last run to our character, right? We never end up reaching this else statement where we add the run to our characters list. The reason we don't reach that is because we never have a scenario where this character, I guess the last character, is not equal to the previous character because the last one here was equal to the previous one. So what we need to do is we need to make sure that we handle the last run in our string explicitly. So let me just get rid of this if statement. I think you guys got the point on this. And I'm just going to show you what we'll have to do after our for loop to make sure that we handle this last run. We'll essentially just have to automatically add whatever our run counter is and the last element in the string to our chars list. So we can simply say chars dot append, right? Imagine we're doing this in, say, a language like Python. We would append our counter, which would be the length. Whatever this length is, I'll show you what happens if the length is, say, 1. And then we'll add the last character in our list. So chars dot append, and then that's going to be string. And this would be the length of string. So I'm just going to put that in the absolute value sign -1. Again, apologize for the mess, but all I'm trying to show you here is that we're going to add the length and then the last character, which in this case would be D, to our characters list. So what that would do for us, since our run counter would be at 2, we wouldn't have reset it. We'll have 2 and we'll have D, and we would have handled that run. Now, of course, we've handled the last run, which is totally fine. We have to take this characters list and we have to convert this into a string. Again, this is not very difficult to do. We'll just have to loop through all of the characters and essentially just create a string with all of those characters and then return that, and that will be the answer to our problem. Now, just quickly, I will show you what happens if our length was, say, 1. So we'll just have a look at actually an example input that maybe actually only has 1 character in it. Because remember, when we start looping at the second character. So what happens if we actually only have 1 character in our input? So let's get rid of this chars list. To erase all of this, we can erase the sample output. We're not going to need that anymore. And let's go here. Chars list is empty. Let's just say our input string is equal to A. So just we get a single A. That's all we get. Well, we have the length at 1. That's what we start at. We're not going to end up looping anywhere, right? Because I really would be the next one over and there's nothing there. So we're going to skip the entire for loop process that I just went through. And we're going to get to the end where what we're going to do is we're simply going to append the length and then the last element in our string to the characters list. So the last element in our string obviously is A. So what we'll do is we'll go up to characters here and we'll just add 1A. So now moving on to the space-time complexity of this algorithm, what we'll determine after we do this analysis is that the time complexity of our algorithm is going to be big O of n, and the space is going to be big O of n as well. Now the space is pretty straightforward, so I'll go through that one first. What we're going to be doing is having this list, as we've already seen here, and what we'll be adding into this list is essentially a bunch of pairs, right? We're going to have some count, and then we're going to have some character. Now we will add at most the amount of letters in the string times 2 characters to this list. The reason for that is imagine we have an input in our worst case that looks like A, B, C, D, E, F, blah, 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 blah. Just imagine that all of these characters are alternating and we actually don't have any runs that are a length of greater than 1. In that situation, we would have to add 2 times the number of characters in this string because we need to add a pair to represent every single character. We would have 1A, we would have 1B, we would have 1C, we would have 1D, and so on and so forth. So really, if we're looking at the space, what we'll say is that what we end up having is a 2n space, right? Where n represents the length of our input string. But since we're looking at big O notation, I can simply remove the constant from in front of this n and just say that our space complexity is going to be big O of n. Again, remembering that as we get to a very large value of n, that 2 that's before it becomes less and less significant, and well, we can simply remove it when we do the big O notation. So that is our space complexity. And now looking at the time complexity, let's see how we come up with that. So we just have to look at the types of operations that we're doing to figure out why our time complexity is going to be big O of n. So what we're doing, and I won't write out the whole code here, is we're going to be creating a list. So we'll do that. We're going to be setting our length to 1. That's an operation. Then what we're going to do after those operations is we're going to have a for loop where we're going to loop through all of the characters in the string. So we're going to say for I equals 1 to n. Now this is just pseudocode. N is simply the length of the string. Keep that in mind. Now inside of this for loop, we're only going to be performing constant time operations. Now we'll look at the exact operations in the next section when we go through the code. Now since they're just going to be constant time operations, what we can say is that this entire for loop, including everything else inside of it, will simply take us big O of n time to complete. So once we're done with this for loop, what we'll have to do is take a look at this characters list, and we'll have to convert this list into a string and then return that string. Now to convert a list of characters into a string, that will take us O n time. The reason for that being that if we look at our space analysis, which we just did, we determined that we have ON space. So if we have at most n elements inside of this character's list, then it will take us ON time to convert this list into a string. Now you might have remembered me saying that we'd have at most 2n characters, which is still correct. So you could theoretically say that it will take us 2n time to convert all of the characters in this list into a string. But again, remembering that we don't care about constants, we can remove the 2, and that leads us up here with big O of n. So really, we're doing 2 big O of n operations. So if we wanted to really write all of this out, we would have O of n plus O of n, and then that would give us, since it's just a summation, it's not a multiplication, big O of n. Because if you wanted to do this, well, what you could say is that big O of n plus big O of n, what is that equal to? Well, that's equal to 2 of big O of n, and then we can just simply get rid of the constants because again, we do not care about the constants when we're doing a space-time complexity analysis. So that has been it for the conceptual overview. Now let's get into the coding. So you can see I have my runline encoding function defined here. It has one parameter. That parameter is called string, and that will be equal to our input string. The first thing that we need to do for our solution is define an empty list that's going to store all of the characters that are going to be in our encoded output string. Next, we'll need to define a variable that can keep track of the current run length as I discussed in the solution. So let's go ahead and get started. Let's say encoded string characters is equal to an empty list. And then let's say current run length equals 1. Remember, we can set this equal to 1 because we know that the string passed in will be non-empty. Next, we'll go ahead and loop through all of the elements in our string. So for I, in range 1, and then the length of string. Then what we'll do inside of here is we'll define 2 variables that will store the current character and the previous character. This will just make it a little bit more readable for us and make the logic a little bit easier to implement below. So first we'll say that the current character is equal to string at index I, and we'll say the previous character is equal to string at index I minus 1, remembering that we started at index 1, so I minus 1 will never be a negative index. Next, we'll say if current character does not equal previous character, or the current run length is equal to 9, now inside of here, we'll implement the logic that will actually add the previous run that we found to our encoded string characters. What I'm saying here is that if the current character is not equal to the previous character, then what we should do is we should take the run that we had found beforehand, so whatever our current run length counter is at, and the previous counter, and we should add those 2 values into the encoded string characters list. Now, we will also do this if the current run length is equal to 9, as I discussed in the conceptual overview. So if one of these 2 conditions is true, then we will add the run to the list. Otherwise, we will go ahead and we will increment the current run length. So let's get started. We're going to say encoded string characters dot append, and we'll start by appending the string value, make sure that we have string here, of the current run length. The reason we need to convert this to a string is because, of course, this is going to be numeric, so we need to have all strings inside of our encoded string characters, so we can then combine all of these strings together into one large output string. Next, we'll say encoded string characters dot append, and we will append the previous character. Now, we don't need to convert this to a string because we know this will be a string value as we've got it right here from actually indexing on the string. The reason we're taking the previous character, again, is because the previous character would have been the end of the longest run that we had just found, or sorry, the run that we had previously found, not necessarily the longest. After we do this, what we'll need to do is reset the current run length, and we're going to reset this to 0. The reason we're not going to reset this to 1 is because no matter what, at the end of our for loop, what we're going to do is add 1 plus equals 1 to our current run length. So just looking through this quickly, we're going to loop through all of the values in our string. We're going to get the current character, we're going to get the previous character, and then we're going to check for this condition. If the current character is not equal to the previous character, or our current run length is equal to 9, then we will append the current run that we found, which will be denoted by the current run length and the previous character. Then we'll reset the current run length equal to 0, and then we will add 1 to our current run length. The reason why we don't need an else statement and we can always add current run length by 1 is because we will reset the run length if we find another run, or if we've already added that run into the encoded string characters. So by doing that and then adding 1, we're essentially just resetting current run length to 1. In the situation where we don't enter this for loop, what that means is that the current character was equal to the previous character and the current run length was not equal to 9, so we can go ahead and increment the current run length. After we do this, what we'll need to do is handle the last run. So this will handle all of the runs for us except for the very last run. So we're going to say encoded string characters dot append, and then just like I showed before, we will append the current run, not current character, the current run length. And then after this, we'll say encoded string characters dot append, and we will append the last element in our string. So we will say string, the len of string -1, and this will index the last character in our string for us. Now remember that since we have a non-empty string, we can be guaranteed that this will work and we will not run into an index error. Again, I have to convert the current run length into a string because that will be a numeric value, so this will handle the last run for us. Now at this point in time in our program, we have an encoded string characters list. This list is complete, we don't need to do anything more with it, and it simply contains all of the pairs that we need to represent all of the runs in our string. So what we must do now is we have to take this list and convert this into a string and return it. So what we'll do is we'll return an empty string .join, and then inside of here, we will pass the encoded string characters. Now, in case you're not aware, what .join will do is create a string out of all of the elements that we pass into this method. Now, it will use whatever we define on the left-hand side of .join, so before the period, as the delimiter for this string. So in the situation where we have an empty string, like right here, we will simply append all of the elements in our list together and create one large string. But if we were to add something into this empty string, say like a period or a pipe, then that is what we would use to delimitate this string. So we get the first character, whatever the delimiter was, the second character, whatever the delimiter was, and so on and so forth. So now our algorithm is complete. And I'll quickly leave a comment here just to remind you of how long this takes to run. So this will run in on time, and this will take on space. And this is where n is the length of the input string. And with that, I'm going to conclude. So I hope this video was helpful for you, and I hope to see you again in another one.